So we're going to come back here and we're actually going to define a midpoint. We're going to define what a midpoint is. So you could put this on your definition sheet. So now that you know what midpoint is, I would like you to write this definition on your definition sheet. So I'll give you a little bit of time to pull that out so that you can be writing this down while I get this ready. Okay, so what a midpoint is, and if you need some more time, you can just pause the video. A midpoint of a segment is the point that bisects I should say the point that divides or bisects the segment into two congruent segments. And I'll move that up so that you can see. A midpoint is the point that divides or bisects the segment into two congruent segments. And bisects is just a word that we use that means to divide something perfectly in half. When something perfectly divides something into two congruent segments, then it bisects. So if we were to go back to our number line example where you have a number line and you're looking for the midpoint. So here are our endpoints and we locate the midpoint right about here. Then this midpoint makes both of these segments, this one from here to here, congruent, makes them equal because it divides it perfectly in half. So that's what a bisector is. So as we're moving along, we have some segment bisectors. So there are some things that can divide a segment in half. So I'll start off with this segment here, and we'll draw exactly what I just had. And a segment bisector is basically anything that can perfectly divide this segment in half. So what can be a segment bisector? Oh, well, here it is. What are the different things that can bisect our segment A and AB? This is segment AB, we would write. Well, it can be a midpoint, like we've already talked about. And you can write these down. I'm not going to write these down, right? But it could just be a point that we call M. Okay. So it could be point M. It could also be a ray. So maybe there's a point here and this ray goes in any direction. It could go up like that, or maybe it goes out like this, or maybe it even goes down like this. But a ray, this ray could bisect a segment. How about this? A line could be a segment bisector. It's a squiggly line, but if we drew a straight line, a line can divide a segment perfectly in half, meaning what is a bisector? A bisector is something that makes two congruent segments. So a line could be a bisector. There are some other things that can be a bisector, but those are the big ones that we'll talk about. Is pretty much a point. It could be another segment. It could be a line, or it can be a ray. So I'm going to come back and I'm just going to make it a point. So I'm going to erase all of this. And on this line AB, I'm going to draw a midpoint that bisects this line. And I'm going to call it M. Now, there's some notation that we do in order to make it clear to everyone that this is a bisector. And remember, we said that if this is a midpoint, then it makes these two segments congruent. It makes AM congruent to MB, which I think is what this says. Yep. Which is the same as saying, once again, and this is important just for notation purposes, that the distance between points A and M is equal to M and B. Now, I could write this out like we've done here, and that would be true, But there's also a way to notate it on the picture, and that's with something that we call tick marks. Okay, and so tick marks tell you what segments are congruent. So if two segments are congruent in one of my pictures, then we just put a little red tick mark through it. Okay, so these two tick marks say this right here. They say that if I just look at this picture and I see these two tick marks, they say that segment AM is congruent to segment MB, and that's which makes M a midpoint. Okay, so you could just see this picture without having this written, and you could know that this statement is true. Okay, there are several things that can be segment bisectors, and the big thing you need to take from this slide is tick marks and what they are. So we're going to continue right along into a practice problem about segment bisectors. It wants you to draw the line CD bisecting segment PR at Q. Okay, I want you to take a second and pause the video and just draw that picture right there. Okay, so let's take a look at what we have here. We're drawing line CD that is bisecting segment PR at Q. Let's just start with segment PR. So I'm just going to draw a segment. And it's segment PR, so that means its endpoints are P and R. And then now I need to draw a line CD that bisects that at point Q. So we're going to say there's point Q about exactly halfway between P and R. And through point Q is a line that we're calling CD. And I can actually label the points if you want to. If it makes it easier for you to label the points, you can, but you don't have to. The points are there whether you label them or not. And then it asks us this. It says find PQ and QR if PQ equals 5x minus 12 and QR equals 3x plus 8. So basically what it's saying is this distance right here is 5x minus 12. And this distance right here is 3x plus 8. So how are we going to solve this? Well, we need to find x first, and the way that we're going to do that is because Q is a midpoint, because this line bisects PR, we know that it makes two congruent segments. And if it makes two congruent segments, then we know that PQ, let's just follow the logic here, that segment PQ is congruent to segment QR, which means the length between P and Q is the same as the length between Q and R. So if PQ is 5x minus 12, then we can write 5x minus 12 equals 3x plus 8, which is QR. And then solve. I'm going to move the 12 over, and I'm going to move the 3x over. So those cross out here. 5x minus 3x is 2x. I need to add 12 here, so 8 plus 12 is 20, and x is 10. Now, are we done? No, because it's asking us to find the distance between P and Q and the distance between Q and R. Remember, that's what this means right here. This means the distance between P and Q. This means the distance between Q and R. So I actually have to go back and plug x in here. So if PQ is 5x minus 12, then I have to go back and plug 10 in for this. So we have 5 times 10, which is 50, minus 12, which is 48. So PQ is 48. And remember, PQ and QR are the same. So if PQ equals 48, then so does QR. Okay, so this is an example of how a bisector, some type of segment bisector, in this case this line is bisecting the segment, so this line is a segment bisector, can help us actually find some values, solve for values when it comes to solving for the lengths of segments. Well, the same is true of an angle. Okay, And we can also have angle bisectors. And what an angle bisector is when something bisects an angle, when it perfectly divides an angle in half. So here, if we go back to when we introduced segment bisector, a segment bisector is something that divides a segment perfectly into two congruent segments. An angle bisector divides an angle into two congruent angles. So if CO, which is a ray right here, if we were to say CO, the ray, bisects the angle AOB, then we know that both of these statements are true. The measure of angle AOC is going to be equal to the measure of angle BOC, right? And that should make sense to you. If this perfectly cuts this angle in half right there, then we know that these two angles should be equal. And there's actually a way that we denote that. If you remember, we denote congruent segments with tick marks. When it comes to angles, we denote congruent angles with arc marks. So I'm going to draw a little arc mark right there. And what this says is any angle that has one red arc mark, those angles are congruent. So this is another way of me writing what these two statements say. That angle AOC is congruent to angle BOC, that the measure of angle AOC equals the measure of angle BOC. Remember, this little m means measure, and measure means we're actually talking about the value, a number value. And these little red arc marks, because there's one in each of these angles, that says they're congruent. Now, if I drew one with one and another with two like that, these angles, this would be saying actually these angles aren't congruent at all. But since we're drawing them each with one, arc marks are how we denote angles that are congruent. And so CO is bisecting this angle. It's perfectly dividing this angle in half. So we can do some math with this as well. So let's take a look at this. If OC bisects angle AOB, find the measure of each angle. How are we going to do that? Well, if OC bisects angle AOB, then what do we know is true? We know that the measure of angle AOC equals the measure of angle COB. So if the measure of angle AOC is equal to x plus 10, then x plus 10 will equal 3x minus 20, since 3x minus 20 is the same as the measure of angle COB. And then we just need to solve. I'm going to add 20 over here and get that away. And I'm going to subtract x from both sides to collect our like terms. So this ends up being 30 equals 2x. So x is 15. Am I done? Not quite, because it's asking me to find the measure of each angle. Oops. Not quite, because it's asking me to find the measure of each angle. Sorry about that. Find the measure of each angle. So x is 15. Then I need to come back and plug this in. So since angle AOC equals x plus 10, I'm just going to plug in a 15 for x, and I know that the measure of angle AOC is 15 plus 10, which is 25, which also happens to be, because this is a bisector and these angles are congruent, we also know that that is also the measure of angle COB. Okay, so there you have it. That is midpoint, segment bisectors, and angle bisectors all in one lesson. What you're going to do now is you're going to go and do the practice problems that are listed on PowerSchool, and this is really, really important lesson in the grand scheme of geometry. So since it is so important, you have a little bit of more practice than you typically would, just to really try and hammer home some of these concepts. And you have the rest of class to finish that.